Hello there, Andrew Dunkley here, the host of Space Nuts. Nice to have your company once again and again and again. We won't go into that. Hope you're well. Stick around because we've got a lot coming up on this episode, and that includes Saturn doing a bit of a moon at us, multiple moons, in fact. Also, the largest cosmic explosion yet seen. We will also be answering audience questions about black holes. Yep. Asteroid redirection, and Paul's got an issue with the Martian movie. We'll find out about all of that and more on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And joining me as always is Professor Fred Watson, astronomer at large. Hi, Fred.
Hi, Andrew. How are you? Sorry, you just disappeared there for a minute. How are you?
Not again.
No, but you came back. That's all right. Yeah, we've had
Good.
the wonderful disappearing act this morning.
Yeah, it's been crazy, hasn't it? I am well. I am really well. And you?
Likewise. Very well.
Oh,
and, I'm, always happy to wake up in the morning and find that nothing's dropped off, or there you go. Comes with a certain age, and you'll get there. Don't worry, you'll get there.
I'm fast approaching. I think most people have sort of seen us plodding along over the last 5 weeks or so, and business as usual. But the fact is, we haven't seen each other for 5 weeks because we've both been away doing these various things. You've been chasing eclipses. I've been swimming around Alaska, thanks to a boat, and Canada, and taking in the sights. It's been wonderful.
Indeed. I know you've had a great time, as indeed did I. We had a wonderful view of the April 20th eclipse off the coast of Western Australia, and a marvellous tour around Arnhem Land and Kakadu, which was very, very hot, but also
I can imagine, even this time of year. Yeah, it's a toasty part of the world. I'll tell you about a few space-related things that happened while I was away. First thing, in Calgary, we went to a restaurant called Major Tom, which they gave us that. It's named after the Space Oddity song by David Bowie, but it's been named Calgary's top restaurant for the last 2 years running. And we had the Canadian national dish while we were there, which is rather lovely. It's just a sort of a Canadian take on chips with stuff on it, but it's a bit more advanced than chips with gravy like we have. I tried to look at the Northern Lights while we were up around Alaska. There were a couple of nights where it was really active, but I missed it for 2 reasons. I think I looked at the wrong time and possibly the wrong direction. And the next night it was raining, so that was disappointing. But when we were in Jasper, I ran across a couple of young people who were standing over behind a counter at reception of the accommodation we stayed at, and they run the Jasper Planetarium. So a big shout out to Jerry and Kayleen. I spoke to them for a few minutes. I'd had a couple of wines, so I'm not sure it made much sense. But there it is, the Jasper Planetarium. So if you're ever in Jasper, go and check it out. They've got a website, jasperplanetarian.com. So, worth having a chat to them. They're lovely people, and it was really enjoyable to catch up. And I told them all about Space Nuts, so they've certainly committed to not listening. And I went to the Space Needle in Seattle. I've even got a Seattle hat. I always get a cap wherever I go. So the Space Needle's amazing. Built in 1962, 63 for the World's Fair.
Yeah.
As was our hotel, built for the World's Fair, which was the Edgewater, where the Beatles famously got a photo taken hanging out the window of their hotel fishing. And I got a photo of that photo. So that's my journey in a nutshell.
Brilliant. Yeah, sounds wonderful.
Yeah, it was great. Really fabulous. A few people might have caught some of the pictures on Facebook because I did share them. Let us get stuck into it because we're under the gun. And first up, Saturn has reclaimed its title as the biggest mooner in the solar system. Naughty Saturn.
That's right. This is a story that I have to say, Andrew, that this really surprised me when I saw it, because the headline is, well, one of the headlines, excuse me, Saturn reclaims its title of Moon King with the discovery of 62 new moons orbiting the planet, bringing the total to 145. Now, for, was it 13 years, we had a marvelous spacecraft in orbit around Saturn that had some very sensitive cameras and did sterling work on our understanding of the planet and its rings and its moons. And I would have thought that if there were any small undiscovered moons lurking around around Saturn, Cassini, the name of the spacecraft, would have found them. That is why it took me quite by surprise. In fact, I'll be honest with you, it took my breath away. 62 moons? How does that work when we've had a spacecraft patrolling around Saturn? And maybe just because maybe Linda Spilker's listening, who is the project scientist for Cassini and a good friend. The problem with a spacecraft like Cassini is that it's got all these really high resolution cameras. It does have some wide field cameras, but it can't look at everything at once. And so the science that it was doing was targeted towards understanding the rings, understanding all the other bits. Of course, we got marvelous photographs of all of those things, Saturn, its moons, everything. Remember Caroline Porco? She was the image scientist for Cassini and became very celebrated as somebody who's produced some of the most marvelous images in the solar system. But it can't look everywhere at once. And that's actually why our good friend Trevor Barry over there in Broken Hill became world famous, an amateur astronomer who was able to look at Saturn with his telescope in Broken Hill and alert the Cassini team to storms and other things of interest like that. So I guess in that regard, Cassini is absolved from any responsibility for missing these 62 moons. But the other thing that I was really impressed by was the way in which these moons have been discovered, because they were discovered not by a spacecraft in orbit around Saturn, not by the James Webb Space Telescope, not by some fancy piece of kit somewhere, but a telescope not very different from our own Anglo-Australian telescope here in New South Wales. And it is the 3.6 metre Canada-France-Hawaii telescope, which has got a nice Canadian flavour to it. Maple. That's right, Maple. It's a team that is actually led by scientists from Taiwan. And what they did was they used the telescope to essentially not track on the stars, which is what you do when you're taking a photograph of the stars. You actually get the telescope to track at the same rate at which the Earth is turning. So that you pick up images of stars as dots, points of light, because usually your exposures might be 15, 20 minutes, sometimes an hour, to build up the faint light on your image sensor. Much different from taking a picture with your mobile phone where it's kind of instantaneous. This is long exposure photography. And so what would happen if you did that and there was a moon of Saturn in the field of view? That moon has got its own motion. And so it's moving against the background of the stars. And that means that the light that falls on the detector is constantly shifting across the detector. And so it just is too faint to be picked up. So what these scientists did was to calculate how they could move the telescope so it would pick up the motion of typical moons around Saturn. And that's how they got the 62 as yet unseen moons, which are, I don't think they're very big. I think they're of order a kilometre or so in size, tiny little worlds, which may have originated possibly in a collision between bigger moons that has essentially, demolished something else to make lots and lots of smaller moons. And one reason they think that might be the case is because several of these moons have got similar orbits. They're moving in paths around Saturn that have kind of similarities, suggesting that they might have come from the same impact event. It seems unlikely that they were formed with Saturn itself, because they're in orbits that are very different from from the like the rings and the moons that sit in the rings.
So that may well answer my question as to how you differentiate a moon around Saturn from the rubble that we know of as the rings. So obviously it comes down to size, constitution,
and orbit. That's right. So the thing about the rings is, yes, you're right. There are millions of what you might call little moonlets in the rings, because they're chunks of ice, up to about 10 meters, I think, in size. But there are moons that sit within the rings, and these are much bigger objects that actually sit in the ring system. And in fact, it's because of the moons in the ring system that you get gaps in the rings as well. There's a sort of gravitational interaction between these things, all these were beautifully captured by images from Cassini. So I think the objects that we're talking about now are in very different orbits. I can't remember the details, but some of them are quite a long way from Saturn, but they're definitely in orbit around Saturn. They've been tracked over a long enough period of time that you can see that they're actually circulating around the planet, and not just random asteroids that are in the same field of view.
Do they have to be a certain size to be considered a moon, or do they just have to be a rock in orbit, a certain orbit?
That's a good question, because what I've just said, that some of the chunks of ice in Saturn's rings are maybe 10 meters across. You might want to call that a moon, because it's it's a sizable object. But I think probably the if I can put it this way, the categorization of what constitutes a moon is probably something that's distinguishable as a single entity, which these tiny chunks of rock around in the rings aren't. So, and of course, you can do that either by its size or by its orbit, or, as you said, by its composition, if it turned out to be rocky, which the rings aren't. They've got a lot of dust in them, but they're not rocky. So, there must be an IAU, International Astronomical Union, definition of what a moon is. And I'm sure in the case of Saturn, it's one that they've had to work hard on, so that they don't include the ring particles as moons. So anyway,
that could get very
messy indeed. So what we're left with is a new value for the number of moons around Saturn, which makes my book Spacewalk completely out of date now. It's gone up to 145, which contrasts with Jupiter, which I think is 95 at the moment.
It's in the 90s. Right. I remember. So, Fred, does this mean that we are likely to find more moons in the future orbiting Saturn and even Jupiter?
It's possible, Andrew. And you might think, well, yes, Jupiter's nearer, so they should be easier to find if there are any tiny objects of this kind in orbit around Jupiter. But just bearing in mind that these 62 newly discovered moons of Saturn, quite a significant fraction of them are thought to be the result of a single collision, where maybe two bigger moons have collided and destroyed themselves. It resulted in many, many fragments.
Yeah.
So that's a particular event, and Jupiter might not have had things like that happening in its past. So that we may be at a stage there that there really is very little left to discover around the orbit around Jupiter in terms of moons.
Well, I guess it remains to be seen, but it's a fabulous discovery, and Saturn regains its title. Of course, if you want to see more moons than that, just go down the main street of Dubbo on a Saturday night. Yep, plenty of new moons there.
Very attractive.
Dear, oh dear. This is Space Nuts with Andrew Dunkley and Professor Fred Watson.
Okay, we checked all four systems and keying with a go.
Space Nuts.
let's, Fred, move on to our next topic. And I think we can get one of our audience members to introduce this one. This is Russ.
Hi, Fred and Andrew. It's Russ here from Stourbridge in Birmingham, the UK. Love the show, guys. I was just wondering if there was any update on the gamma ray burst known as the boat, the biggest of all time, that we detected last month. And there seemed to be some evidence of super high energy particles that we detected that could potentially explain what dark matter is. I haven't heard anything about it since, so I was just wondering if you could give us an update. Thanks a lot, guys. Take care. Goodbye.
Thank you, Russ. It's coincidental that Russ should send that question in because Fred had put it on the topic list for us for this week before I knew the question had arrived. So he's right on the money. The largest cosmic explosion yet seen. Not the brightest, but the biggest.
Actually, we are talking about two different things here.
Oh, we aren't, are we?
Yes, but this is not the boat. This is one that beats the boat into bits.
Well, we can talk
about both boats, yeah. I forgot. So I beg your pardon. I forgot. What's that gentleman's name there who was just talking to us? Russ. Thank you, Russ. Russ is he's on the money in that we're seeing some very bright events. The gamma ray burst that Russ is talking about, nicknamed boat for brightest of all time, that took place last October, or it was detected last October. But it was a gamma ray burst. It was a brief flash of gamma radiation. I don't know, because I didn't pick up on the details there. I haven't had time to look at this since you've only just raised it again. I don't know whether there was an optical counterpart found. What that means is finding a visible light equivalent. And I hadn't heard about the implications for dark matter. So thanks, Russ, for the heads up on that. I will.
We might follow that up.
Absolutely, we'll do that. Try and do that for next time. But
well, it's a good thing I made that blunder because they're both being called boats.
Well, this one's called AT2021LWX, which is not spelt BOAT.
Yeah, but biggest of all time.
Well, actually, boat was brightest of all time. So this might be biggest of all time. You could be right because it is. That's the exactly how it's being portrayed. Now, just coming back to Earth, if we can, I might read you the title of the paper in which these results were published, because the headlines all say things like astronomers puzzled by largest cosmic explosion ever seen, biggest explosion ever recorded, etc. The title in the Monthly Notices article is Multi-Wavelength Observations of the Extraordinary Accretion Event AT 2021 LWX. It's a lot quieter. But when you read the abstract, you get the feel that there is good stuff here. It begins, we present observations from X-ray to mid-infrared wavelengths of the most energetic non-quasar transient ever observed. So a transient is something where there's radiation, which usually comes and goes, which is where the transient term comes from. But this has come and has not yet gone. It's an explosion that has been taking place for the last 3 years. Basically, it was an event that was spotted actually again by a telescope in California that has similarities with one of the telescopes that we have here at Siding Spring Observatory in New South Wales, not the Anglo-Australian telescope, which I mentioned a few minutes ago, but the United Kingdom Schmidt telescope, which I used to work on in very great detail back in the 80s and 90s. So there's a telescope in California that is almost identical. In fact, our Schmidt telescope was a copy of it, effectively, although there were mods made. This thing is now called the Zwicky Transient Facility, and it's on the Ocean Schmidt telescope at Mount Palomar. And that basically is used to record the sky repeatedly over relatively short time intervals to look for things that come and go. And so that might include supernovae, exploding stars. It might include asteroids. I think they churn out many asteroids discoveries in their work. But back in 2020, the telescope was doing its usual automated sky sweep, and it picked up this bright object, which shocked people because when they followed it up, they discovered that it was, I think it's 8 billion light years away. It is, yeah, exactly. It's a long, long way off. And that meant that basically the energy that they were recording is very, very high. And one of the lead authors of this work, Philip Wiseman, who's at the University of Southampton in the UK, he made the comment that the estimate for its brightness is, wait for it, 2 trillion times brighter than the sun.
Blimey.
Yeah.
Good grief.
And so, what is it? Well, what they've done very wisely is followed up in wavelengths, as it said, from X-rays up to mid-infrared. And that rules out some of the possibilities. It's by doing that you find out that it's 8 billion light years away, because you measure its redshift. And so it's really an extraordinary object. And the sheer energy of what it's putting out rules out the possibility of it being a supernova, an exploding star, because it's 10 times brighter. And with supernovae, exploding stars, they generally come up to a peak brightness. There are many different kinds of supernovae, so they all behave slightly differently, but they usually fade within a matter of days or weeks after that peak brightness. This thing is kind of still going. It has started fading, but its fade is very gradual. It's occupying hundreds of days. And in fact, as I said, it's been bright for 3 years, which means that it's something more than an exploding star, and that there is an enormous amount of energy coming out. I mean, it's still bright. It's still effectively a fireball. And so the best bet that they have in terms of interpreting what it is okay, you start with the most energetic objects we know about, which are black holes. So a supermassive black hole in the center of a galaxy, which incidentally they can't see. So that's weird as well. But if you've got a supermassive black hole with a disk of material around it, that, as we know, because we've talked about this many times, this stuff swirls around, is raised to very high energies by the friction that's caused during this swirling around. It's called the accretion disk. And then some of it disappears into the black hole. Some of it gets shot out by magnetic fields. But the bottom line is you get a lot of energy coming from these things. And that's what we normally call a quasar, an outburst in the center of a galaxy that comes from material being sucked in. But they are variable on much shorter timescales than this one. And so the interpretation is that, yes, this is the scenario. You've got a supermassive black hole, stuff swirling around it. But what has actually gone into this disk of swirling material is a very, very large, what we call a giant molecular cloud, a cloud of gas, basically. And that I'll just read the last sentence of the abstract of the paper by Philip Wiseman et al. It says, a plausible scenario is the accretion of a giant molecular cloud by a dormant black hole, in other words, one that's not been doing too much before that, of 10 to the 8 to 10 to the 9th solar masses. That's the size of the black hole. It's of the order of 1 billion solar masses. And so you've got a large cloud of gas that is so big that it takes a long time for the black hole to gobble it up. They make the comment, AT 2021 LWX thus represents an extreme extension of the known scenarios of black hole accretion. In other words, it is really a one-off, and that's why it is a record holder.
Extraordinary. Yeah, that's a huge, huge boom. I guess they'll do some more study and try and confirm their theories. That's what you do, I suppose, and maybe we'll know in the future exactly.
Yeah, that's right. I mean, what we're seeing at the moment is we've got what are called light curves here, which are still being produced, and a light curve of this object showing how it's increased in brightness, and its increase was relatively general. It took something like 100 days to get from not being visible at all up to the kind of brightness that it has now. So it's a gentle increase, but is now being followed by an even more gentle decrease in brightness. So these are all measurements of what we call its magnitude, its brightness, and there it is.
Like a Roman candle.
That's right. Unlike most supernovae, which are more like what we used to call a banger, but I think here it's called a bunger.
Yeah, a bunger. Yes, indeed. All right, there'll probably be more to come on that particular story. This is Space Nuts, Andrew Dunkley with Professor Fred Watson.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Now, Fred, let's get into the Q&A session where we hand it over to the audience to come up with some questions for us. And the first one comes from Clyde.
Hi, Fred and Andrew. It's Clive from England. Thanks so much for the show. I love it. I'm an avid follower. Fred said something very interesting in the last episode, which is about black holes made from dark matter. And it struck me there wouldn't, as far as I can guess, be any difference between a black hole made of dark matter and a black hole made of ordinary matter. So does that imply that are they the same first? And does it imply that black holes could be hoovering up dark matter as well as ordinary matter? I'd love to know what you think about that. It's a great conjecture by Fred, so thank you very much. Cheers.
Thank you, Clyde. Dark matter and black hole questions are not uncommon.
Got them both.
And here we've
which
put
is
the
great,
two together.
Actually. And it kind of, in some ways, ties in with that paper we discussed recently that also says that dark energy might be due to black holes. So, maybe
yes, that's right.
Black holes are really the secret of everything. All the big questions that we've got, the only one that they might not answer is, are we alone? Anyway, so Clyde, that's, your thinking along those lines is interesting because I think you're right that given that the phenomenon about dark matter that reveals its dark matter is its gravitation, and gravitation is all you need to make a black hole. So
that's a Beatles song, isn't it? Gravitation is all you need.
Gravitation is all you need. A hit song in 1967. I remember it well. And of course, it winds up with. I think it's In the Mood. It's one of the old swing band songs that comes in at the end there, as well as She Loves You. Yeah, gravitational.
That's right.
Anyway, I've forgotten where we got to. So that gravitation. All right, gravitation is what generates a black hole, and yes, why not have dark matter in black holes? I really need to follow up on this because there will be work on it in the literature. Is there any reason why we don't think that dark matter is swallowed up by black holes? And does that mean that in the gravitational potential well that is a black hole, there's a mixture of normal and dark matter, which kind of makes sense because there's a mixture of it outside black holes as well. In fact, we know it's here.
Yeah.
And there where you are, it's wherever normal matter is. Great question. And let me follow up again on that and see whether we can get some answers on it.
Okay. Thank you, Clyde. Couldn't come up with all the answers today, but we're talking black holes and dark matter. So there's still a lot of unanswered questions regarding that and dark energy, of course. Let's go now to Mikey.
Hey, Fred and Andrew, it's Mikey from Illinois. So a while back now, you guys had an episode on asteroid redirection and asteroid threats and how we would avoid such things. And you guys had mentioned nuclear bombs, could be an option. And it got me thinking, and I've been thinking about it ever since, and I've been meaning to ask you guys this, but time just gets away from you. But if we did have to send a nuclear bomb on a rocket to destroy an asteroid that was too big to redirect or, whatnot, rockets fail. And unfortunately, we've seen this before in the past, and it got me wondering what happens if a rocket fails with a nuke strapped to it when we're trying to redirect an asteroid or destroy an asteroid in this case. I guess there's just always that potential, and I had never thought about it. I mean, am I right in this? In that, there could be a rocket failure in a scenario like this, and then what happens here on Earth? I mean, I guess it would depend on how big the nuke is. I mean, what kind of destruction would we be looking at? Am I thinking right? Like, that is definitely a possibility. Just a quick what if, that never crossed my mind. And hope you guys have a good one. Enjoy the podcast. Thank you.
Oh, Mikey got cut off, but thank you, Mikey, and thank you for putting that terrible nightmare into my brain. First and foremost, if we were to put a nuke on a rocket, I wouldn't be contracting Elon Musk to send it up at the moment. But yeah, the rockets fail. It's a fact of life, and most don't. But you don't really want one carrying something like this to fail. But Fred, I would suspect that the way they make nuclear weapons, there are lots of fail-safes built in.
I think that's true, Andrew. And
notwithstanding the possibility of it cracking open and the
fissile material,
nuclear energy being released.
So a number of points to pick up on here. One is just I don't often leap to Elon's defense, but his whole philosophy of making reliable rockets is to test by failure. And it's a different scenario from the way NASA works. But he can do it because he's not using public money. Well, he is to some extent, but you know what I mean? It's a private company. And so the spectacular failure on the 20th of April of the Starship, the first Starship flight, which failed because of a fault in the second stage separating from the first. It wasn't actually the rocket itself that blew up. It failed to separate, and so that produced an instability, and they had to destroy the rocket. But Elon will take stuff from that and learn from it, and hopefully next time it'll have a better outcome. Now that's
look, I was tongue in cheek, but I do have a lot of respect for him, and
just to set them.
And it wasn't until I was in Canada and Alaska that I saw why he's got so much money to pour into rockets, because the number of Teslas on the road is outstandingly amazing. They are everywhere.
I mean, that's why we respect Elon, for exactly those reasons. We've got all these electric cars. We've got reusable spacecraft. It is amazing. There's other things that we don't quite feel so respectful about, but that's all right. Anyway, but you're right.
That's life.
Rockets, you've got a bomb sitting there with something very precious on top of it, whether that's a human or a nuclear warhead. So you're always running risks. I think the bottom line is, though, and it is possible that we might need nuclear weapons, not actually to demolish an asteroid, but to deflect it by the shock wave, the blast. You explode the device next to it, and the shockwave actually pushes the asteroid or accelerates it slightly. You and I covered a story probably a few months ago where it turns out that rubble pile asteroids are actually more resilient to that kind of thing than you'd think they would be. I think they just get to bits, but they actually apparently would be easier to deflect, and that's something that will feed into the whole idea of planetary protection. So I think the crux of the matter here is that you would only be doing that in extremis. You would only think about sending nuclear weapons into space because it kind of contravenes the international space law effectively. You would only do it if that was the only way to avoid an impact by an asteroid down the track, which might result in much higher loss of life than a nuclear explosion on a launch pad.
Yeah, but we're talking bureaucrats here. We want to send a nuclear weapon into space to deflect an asteroid that is going to destroy humanity. No, you can't do it. It says so right there.
That's right. And that might be the answer in the end. But it would have to be literally the only possible option. I think that's right. But yeah, Mikey.
But as for the rocket failing with a nuclear weapon on board, the bombs are designed not to explode if there's a disaster. But whether or not the cataclysmic explosion or whatever it is that brings the rocket down causes the nuclear warhead to crack open and expose us to radiation, that's another matter.
It is. And those are all possible scenarios. You're absolutely right. So Mikey's raised an interesting, it's almost a philosophical, an ethical question, really, isn't it, about whether we should...
Yeah, it is.
We should do that.
Is the risk worth the reward?
I think that will be the equation that would have to be sorted out by, yes, the bureaucrats and anybody else who's involved with it.
Because the other option, and we can't do it now, but we could just build the bomb in space and launch it from beyond our atmosphere.
That might also be possible. That's a good suggestion. I mean, I don't know, uranium centrifuges in space to refine uranium. That sounds like the sort of thing that would also raise hackles. I think you'd need to be in a scenario where the world was united in realizing that this was the only way to deflect this asteroid and avoid a catastrophe. Because otherwise you'd have, the committee that I was involved with at the beginning of the year, COPROS, the Committee on the Peaceful Uses of Outer Space. Yes, sending a nuclear weapon to an asteroid is part of the peaceful uses of outer space, but is not, sorry, I'm just going to do that. It's not something that would normally be thought of as a peaceful venture to send a nuclear rocket into space. A nuclear missile into space.
Indeed. Good question, Mikey, and very interesting to discuss, and maybe we'll get to talk more on it in the future. Finally, Fred, we've had questions about the movie The Martian several times and discussed some of the feasibility of the things they portrayed in that film, including growing potatoes on the moon. Paul has an observation.
G'day, Professor Fred and Andrew. This is Paul from sunny Brisbane Vegas in Queensland, Australia. I have a question about that awesome movie, The Martian. There is one thing that has been baffling. It's this. At the start of the movie, there's this spaceship that's being threatened by this huge dust storm and these, we're not in Kansas anymore, Toto winds that are going to knock it over. So the astronauts had to get on board and leave Matty Damon in the you-know-what, quite literally. I get the impression that that's just not going to happen because Mars's atmosphere is, 2% of Earth's, so there's very little air pressure, and the winds just can't push over anything that heavy, let alone the rovers that are already on there. Am I right? And if I am right, is that okay? It's not like they were making a movie like Star Trek or Star Wars, which is more like, space opera rather than science fiction. So are they doing scientists and science a little bit of a disservice by fudging things like that when they try and get everything else right? I don't know. It's probably nothing, but nevertheless, I just thought it was food for thought. So keep up the excellent work, gentlemen, and have a good one. Thank you.
Thank you, Paul. It's a great question, and it brings up another element that I had trouble with, and that was at the end of the film, his rescue, where he had to drive 3,000 miles to get to another rocket ship to take him off the planet, which they'd already deployed on the planet, which didn't make sense to me. How can you already deploy an Earth return vehicle when there was nobody to return, and they've got to... No, it didn't gel. It was just sort of a throwaway, we better figure out a way to get a rocket to him. Well, let's already have it there. So that part of the story I thought was a bit iffy. But yes, the storms on Mars, they can be quite volatile, though, can't they, Fred?
Yes, they certainly, they're capable of producing global dust storms, which tells you that they're significant. Paul's absolutely right, though. The pressure is low. It's actually 0.6% of Earth's atmospheric pressure. The reason why we can get global dust storms blown up by winds in such a rarefied atmosphere is that the dust is very fine. It's extremely fine, very easy to lift up. We've got these dust devils that we see on Mars, little whirlwinds. But Paul's absolutely right. Winds, even though they might be quite high speed, but within an atmosphere that thin, are not going to knock over solid pieces of steel or titanium or whatever it is.
Is that right?
So they're winds, but I think Paul's right that that scenario wouldn't happen. There were a lot of other things. The one thing that bothered me about The Martian, and it's along the same lines. If I remember rightly, there was a bit where he had almost like a tent or something, which had a hole in it, which he patched up with a sheet of.
That was in the habitat where he was growing the potatoes, and the entryway, the airlock blew off, and he patched it up with plastic.
But wasn't it the outside that he patched up?
Yes, yeah. He put the plastic on the what was the opening to the airlock and patched it up with plastic and tied. I mean,
it's essentially
nylon or something
out there. So that bit of plastic would have bulged and probably burst just by virtue of the atmospheric pressure within it. So that upset me a bit, and you were clearly upset by the logic of having a spacecraft there. So,
already unmanned, conveniently ready to take him home. I mean, you've got to take a little bit of latitude in creating the story. A lot of it was well researched, and they did a fabulous job. And the growing of potatoes angle actually would work.
So we're here. But Paul's bigger question is the philosophy of how you portray a science fiction or a space opera type scenario, whether we are playing to something completely fictional or whether we're a mixture of both, which I guess The Martian was. A bit like the movie Gravity, that was a mixture of fact and fiction as well.
I think it had a lot more creative license added to it than The Martian, though. Some of the stuff they pulled off there was probably, 1 in a trillion chance of surviving scenarios, and she did it 4 times.
The one that, and I always come back to this one, the one that stuck with the physics, at least for the first, I guess 80% of the movie was 2001: A Space Odyssey, because that everything that was in there was feasible, and it was only at the end where we went off into, a different dimension of space-time, courtesy of the aliens. That was the bit that, and it didn't worry me at all, didn't that? Because I accepted the fact that we're in new territory here, so we can't call the odds.
That movie was actually one of the options on my flight to and from Canada, and I was going to watch it, but I fell asleep, which is good. I actually slept. Coming home, I slept for 7 hours and tricked my brain into thinking I was still in Western Canadian time. And when I woke up, it was early morning in Sydney, and I was in sync. So I actually managed to trick my brain into avoiding jet lag this time around. Yeah, 7 hours sleep on a plane in a 15-hour flight. I was very impressed. I've never done that before. Probably never will again. Thank you, Paul. That was a great question, and you were right. Yes, the storms up there would not knock the rocket over. And the other thing I noticed is, because you said the storms only have minor dust particles, This one was lifting up rocks, like the size of a coin type of thing. So that was a bit of a misnomer as well. Fred, that wraps it up. Don't forget, if you've got questions for us, please send them to us via our website, spacenutspodcast.com or spacenuts.io. And you can send text and audio questions that way. And don't forget to have a look around while you're there. And if you want to think about becoming a patron of Space Nuts, by all means, look into that as well. We'll never force you to pay for it, but if you want to voluntarily put some money in the kitty to pay for a new internet connection or something, that would be most welcome. We've had a fun time today. Yeah. And thanks to Hugh back in the studio. As always, he's had 5 weeks off. And of course, today he thought he was still having time off. And that's probably why we dropped out 5 or 6 times during the recording. Fred, as always, thank you. We'll catch you next week.
I look forward to it. Good to see you back again. And I love the cap.
Oh, yes, I do too. It's a nice colour. And I loved Seattle. What a beautiful city. Beautiful city.
Take care. Bye.
See you soon, Fred. Fred Watson, astronomer at large, part of the overwhelmingly large team of 3 here at Space Nuts. And from me, Andrew Dunkley, thanks for your company. Catch you on the very next episode. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.